of the universe, physics at the quantum scale, and biophysics.
Biophysics is an interdisciplinary field that lies at the interface of physics, chemistry, and biology. So biophysics, which is an emerging field, has a lot to promise by basically developing more advanced techniques and more advanced theoretical tools to understand the mechanism in biology.
The history of astrophysics at Berkeley, and particularly in the physics department, is really wonderful. There's been a number of really fundamental discoveries made at Berkeley, leading to some recent Nobel Prizes.
The greatest strengths of this department are unequivocally its people. It's the faculty, the students, the undergraduates and graduate students, and the staff.
My research is focused on the study of nanostructures. I'm an experimentalist, and so I perform experiments on different types of nanostructures. Some of the potential applications of my research would be, for example, in the miniaturization of different kinds of devices. As you make devices smaller and smaller, people are interested in incorporating nanostructures into electronic devices.
I have developed a fluorescence technique that can locate the position of one dye molecule with 1 nanometer precision. And we apply this method to understand how molecular motors walk inside cells. These are nature's tiniest bipedals.
In my research, we build telescopes and detectors that go behind the telescopes, and these are all to look at the cosmic microwave background, which is the faint radio background radiation that's left over from the Big Bang.
My research overlaps considerably with the work of condensed matter theorists.
We are in an era where there is a very close connection between experimentalists and theorists. There is a lot of interest by many theorists in the results that we're producing.
Collaborations amongst physicists are a crucial aspect. You don't do it by yourself, basically. Once we have a theory and we're excited about it, it's straight back to our experimental friends to figure out how can we test this theory. And I think that's, in a sense, the most exciting bit.
So really we do everything from A to Z that you need to do to answer the physics question. And that's very characteristic of a physics department approach to doing research.
Students in the Berkeley Physics Department have an enormous range of opportunities. The researchers here are engaged in some of the most exciting research anywhere. There's just an enormous range of opportunities. I think it's just a great place to go to school for them.
At graduate school, you're learning how to think as a physicist.